everybody, we're back. We're going to be looking at graphs today. So this is your introduction to interpreting graphs. So I want to start by showing you a couple of different types of graphs that you may see. Okay, so we have to think back to math class. When you look at graphs, that's usually where you're introduced to graphs. We have different ways that graphs can look. So we have graphs that look like this with the X and the Y on the side of the graph. You have graphs that show all four quadrants, quadrant 1, 2, 3, and 4. And you have graphs that show only 2 of the quadrants. For science, for physics, mostly we're dealing with graphs that either show just quadrant 1, like this one, or graphs that show quadrants 1 and 4 only. The reason for this is because in the real world, we are only dealing with increasing time, positive time. So when we're moving to the right in a graph, this is increasing and this is decreasing on the x-axis. So we cannot go back in time if we go into quadrants 2 or quadrants 3 of a graph. This is going back in time. So we are only dealing with quadrants 1 and 2 or quadrant 1 like this one. Okay, so I just wanted to remind you for a minute about the graphs and how they look so we're not confused when we're looking at these graphs, okay? So let's take a look at our practice problems for today. We're going to be looking at some graphs and interpreting them. So the graphs that we're looking at here is showing quadrant 1 and quadrant 4. So we have the x-axis in the center, so you see the 0 right here, and then the y-axis positive and the y-axis negative on the side. So you can see here, this is time, and this is position or distance on the side. Okay, so let's look at our questions. The first question says, what is plotted on the x-axis? What are the units? So the x is here. So this is time in seconds. Okay, question 2. What is plotted on the y-axis and what are the units? So the y is here. So this is position in meters. Remember, M is meters, M is not miles. We're doing metric system for science. All right, question number 3. How much is each division on the x-axis? So we're looking at the x-axis and we want to know each of these little hash marks, the grid that's being made here, what do they represent? So I have 0, 20, 40, 60, 10. So we need to count. 1, 2, 3, 4, 5. So I have 5 in between here. So if we count by 2s, 2, 4, 6, 8, 10, that's not quite enough. So it's going to be 3. If it's by 3s, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's not quite enough either. So if we count by 4s, 4, 8, 12, 16, and 20. Okay, so this is counting by 4s. Then we're going to look at the same question for the y-axis. How much is each division on the y? So if we look here, this is counting by 10s, 10, 20, 30, 40, and I only have 1 hash in between. So this is going to be 5, 10, 15, 20, 25, 30, 35, and 40. So these are counting by 5s. Okay, so this is 4 meters each and 5 seconds each. Question 5, what is the independent variable? So remember, the independent variable is the variable that I can control or I can set. So the independent variable is always on the x-axis. So this is going to be the time. And the dependent variable is the one that responds or depends on the other variable. So that's going to be the position. So on the x-axis, this is the manipulated or the independent variable. On the y-axis, this is the dependent or the responding variable. Okay. All right, the next question, what is the initial position for x? So on the x-axis, where are we starting at? So our graph starts right here, which is the 0 on the x-axis. What is the final position on the x-axis? So we're ending right here, and that is also on the 0. Number 9, during what time interval is the person not moving? So remember back to our notes that we took the other day. If we have no motion, that's represented by a horizontal line. So if we look here, we can see a horizontal line right here on our graph and right here on our graph. So the object is moving, it gets to 30, it stays at 30, stays at 30, stays at 30, then it's returning back towards the starting position. It goes behind the starting position down to 40 meters behind where it started. It stays there, it stays there, it stays there, it's still at 40, and then it returns back to where it started. Okay, so during what time interval is the person not moving? So we're going to look here. During this time interval here, so between 16 and 24 seconds, so 16 to 24 seconds, it's not moving. And then also over here, it's not moving, which is 44 to 60 seconds. Okay, so we have 2 time intervals in which it's not moving. Okay, then it says, during what time interval is the person moving forward? A forward motion is represented on this type of graph as a upward on the graph. Okay, so forward equals upward on a position versus time graph. So we're moving forward here. So forward I'll do in green. So here is moving forward because this is a upward sloping line, and here is moving forward, which is an upward sloping line. So this is asking for the times that the person is moving forward. So between 0 and 16 seconds, and also between 60 and, what is this, 64, 68, 72 seconds. Okay. Okay, during what time interval is the person moving backwards? So backwards motion is going down, a downward sloping line. So backwards is a downward sloping line. Okay, so let's look here. He's moving down all of this time right here. It's different slopes, so he's moving at different speeds, but his motion is going backwards that whole time. Okay, so this is right here that we said at about 24 seconds. I'm lying, that's, yeah, 24 seconds all the way to here, which is about 44 seconds. So to here. Okay, and question number 12. What is the distance traveled on the journey? So here we're asking for distance, which is the total. So we need to add all of the x's together. Okay, so first he's going from 0 up to 30. And that's our first leg of our journey. So we have 30 meters. Okay, here he's not moving, so this is 0 meters. Then we're going from 30 all the way down to here, which is negative 40. So 30 to negative 40 is 70 meters. Then here it's not moving, so it's 0. And then we're going to come back up from negative 40 to 0, so that's another 40 meters. Okay, so we're going to add all that together to figure out the total distance traveled. So 30 plus 0 plus 70 plus 0 plus 40 gives us 140 meters. All right, the next one is asking for displacement. Remember that displacement is different. Displacement is how far you are from where you started. So for this one, we started and we ended at the same position on the x-axis at position 0. Okay, so the total displacement, even though we went all these different places, because we start and end at the same place, is still going to be 0 meters. And the last one, number 14, what is the average speed for the entire trip? So remember, speed is distance divided by time. So we're going to take our total distance, which we already calculated right here, which is 140. And we're going to divide it by the total time, which you can see is 80 seconds. Remember, whatever's on the top goes into your calculator first. So 140 divided by 80 will give you 1.75. And that's meters per second. Okay, question 15 is asking what is the average velocity? So for velocity, we're using displacement and we're using time. So the displacement is 0 divided by the time of 80. So 0 divided by 80, 0 divided by anything gives you 0 meters per second. Okay, and the last question, what is the highest instantaneous velocity for the entire trip? So for this one, we need to calculate the velocity for each segment of our trip. Okay, so segment 1 right here, we have distance of 30 divided by time of 16. Okay, so that's 30 divided by 16 will give us 1.9. Okay, so segment 1 has a velocity of 1.9. Here it's not moving, so we know that's going to be 0. The next segment coming down is starting at 30 and coming down to -10, so that's a distance of 40. And the time is from 24 to 28, so that's 4 seconds. So 40 divided by 4 gives you 10 meters per second. That's probably going to be the fastest one. We can see the slope there is very great. Okay, segment 3 starts at -10 and goes down to -40, so that's 30 distance. And the time interval here is from about 28 over to 44. So 44 minus 28 is 16. So 30 divided by 16 is again 1.9. Okay, so the fastest, oh, and then this is 0, and this segment here is distance of, so it's going from -40 to 0, so that's going to be 40. And the time here is 12. So 40 over 12 gives you 3.3. So the fastest one is going to be 10 meters per second. All right, so I hope that helped you interpret some graphs. So try some more and let us know how you do. Have a good day.